Good morning, students. This is Murthy sir. In the last class, we discussed about quantum numbers. Today, we will discuss one interesting topic, the electronic configuration. What is electronic configuration and what are the principles involved in it? And we will see different examples how to write it. To write electronic configuration of elements, we follow NLX method. N stands for principal quantum number, L stands for subshell, and X number of electrons. The distribution of electrons in the main shells, subshells, and orbitals is known as electronic configuration. It is represented by NLX. N is principal quantum number, L is subshell, and X number of electrons. Electron symbol is E minus. Students, in the modern periodic table, 118 elements are there. In that, around 90 elements are naturally occurring, and remaining 28 elements or synthetic elements. It is possible to write electronic configuration for all these elements by following this NLX method. First, we have to see the atomic number. Atomic number is represented by symbol Z. Based on the atomic number, we can write electronic configuration. Students, here you can see two examples. Hydrogen, the electronic configuration is 1s1. Helium, 1s2. Hydrogen has 1 electron and helium, it has 2 electrons. So the number 1 is main shell, principal quantum number, and L is subshell, S, it belongs to S subshell, and hydrogen has 1 electron, so 1s1 and 1s2 in case of helium because it has 2 electrons. To describe electronic configuration of elements with more than 1 electron, we should follow 3 principles. They are Aufbau principle, Pauli's exclusion principle, and Hund's rule. Let us see what is Aufbau principle. The orbitals of lower energy are filled first with electrons, and only then the orbitals of higher energy are filled. Students, this Aufbau principle was proposed by Niels Bohr and Wolfgang Pauli. The meaning of the word Aufbau is building up. It's a German word. Students, this Niels Bohr and Wolfgang Pauli both contributed for the study of structure of atom. So they formulated this Aufbau principle. The meaning of the word Aufbau is building up. So according to Aufbau principle, the electrons are filled first in orbitals of lower energy and then it goes to orbitals of higher energy. Here you can see the photographs of Niels Bohr and Wolfgang Pauli who formulated Aufbau principle. And here you can see the order in which subshells are filled with electrons. There is a certain order based on Aufbau principle, and this is called molar chart. How the electrons are filled in a particular order. So that is molar chart, and while writing electronic configuration of different elements, we have to follow that. But few elements are exceptional to this. That we will come to know. Now let us see Pauli's exclusion principle. No two electrons of the same atom can have all the 4 quantum numbers the same. It was proposed by a great scientist, Wolfgang Pauli. Already have seen his photograph. He contributed for Aufbau principle also. So according to this Pauli's exclusion principle, if you take the different electrons of an atom, the first 3 quantum numbers may be the same, but the spin movement of the electron, clockwise spin and anti-clockwise spin, that differs mostly. Students, already we learned about 4 types of quantum numbers. So based on this Pauli's exclusion principle, so the last one, spin quantum number, may change. In case of one electron, it is plus half, and in case of another electron, maybe it is minus half. Here you can see that representation of spin quantum number. Students, the third principle is Hund's rule of maximum multiplicity. According to this rule, the electrons start pairing only when all the degenerate orbitals of a subshell are singly occupied with parallel spins. Already you learnt about degenerate orbitals. The orbitals possessing same energy, same amount of energy, are called degenerate orbitals. So this is third principle. Students, this third principle, Hund's rule, it was proposed by a scientist named Frederick Hund. So all these three principles of Bohr principle, Pauli's exclusion principle, and Hund's rule. So these three principles we had to follow while writing electronic configuration of different elements. But already, as I told, few elements, they are exceptional. They deviate from this. So that we will come to know when we see the different examples. So here you can see the correct way of representation of electronic configuration, and below you can see the wrong one. So based on the atomic number, when we write electronic configuration, here you can see the electronic configuration of nitrogen. And nitrogen atomic number is 7. 1s2, 2s2, 2p3. Let us see the different examples. Boron, atomic number 5. The electronic configuration is 1s2, 2s2, 2p1. Carbon, atomic number 6. 1s2, 2s2, 2p2. Nitrogen, atomic number 7. 1s2, 2s2, 2p3. Oxygen, atomic number 8. 1s2, 2s2, 2p4. So like this we have to represent. Students, when we see the electronic configuration of nitrogen, 1s2, 2s2, 2p3, p orbitals are half-filled. So this half-filled state shows stability. Nitrogen is stable because of the 3 half-filled p orbitals. You know, nitrogen is somewhat inert in nature. It will not react easily with other elements because of this stability. Fully filled orbitals show stability like inert gases or noble gases, and this half-filled state also shows stability. Now let us see the electronic configuration of oxygen. 1s2, 2s2, 2p4. Fluorine. We can show helium in brackets, that is noble gas, and 2s2, 2p5. So the atomic number is 9. So like this also we can represent. Neon, 1s2, 2s2, 2p6. So atomic number is 10. Friends, the neon is a noble gas or inert gas. It has 8 electrons in the outermost shell. Now let us see silicon. Neon, it is shown in brackets, followed by 3s2, 3p2, atomic number 14. So this is an easy way of representation of electronic configuration. Sulfur, atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4. So this is usual way of writing. Like this we can write, or the noble gas showing in brackets followed by the remaining electronic configuration. Chlorine, here you see neon is shown in brackets followed by 3s2, 3p5. Chlorine atomic number 17. So we can write like this. This is easy way of writing the electronic configuration. Chlorine belongs to halogens. Halogens are one group of elements in the periodic table. Argon, it's a noble gas. 1s2, 2s2, 2p6, 3s2, 3p6. The atomic number is 18. See, outermost shell, 8 electrons are there. It is stable state. Argon is a noble or inert gas. Now let us see the electronic configuration of calcium. Atomic number 20. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So this is the normal way of writing electronic configuration. Now let us see the electronic configuration of chromium, atomic number 24. It is shown argon in brackets 3d5, 4s1. It is an exceptional element which deviates from Aufbau principle. Copper, atomic number 29, argon is shown in brackets 3d10, 4s1. This is also an exceptional element which deviates from Aufbau principle. Students, this chromium and copper are the two familiar examples for exceptional elements which deviate from Aufbau principle. Students, let us see zinc. Atomic number 30. Argon is shown in brackets 3d10, 4s2. This is the easy way of showing the electronic configuration. Noble gas is shown in brackets followed by the remaining electronic configuration. Krypton, it's a noble gas or inert gas. Atomic number 36. Students, you can see 8 electrons in the outermost shell, which shows stability. Krypton is a noble or inert gas. Now let us see silver. Atomic number 47. Krypton is shown in brackets followed by 4d10, 5s1.